Welcome to your online class. Let's start our lesson of the day. We have been studying organic compounds, the hydrocarbons, and the derivatives. In the previous lecture, we discussed some of the derivatives of hydrocarbons. We discussed the alkyl halides and the alcohols. Today we are going to continue our previous lecture. Today's lecture is a continuation of the previous lecture, introduction to the hydrocarbons and derivatives. So we have phenol here. Phenol is another derivative of the hydrocarbons. A phenol molecule can be obtained by replacing one of the hydrogen atoms of benzene. This is a benzene molecule. It has got 6 carbon atoms and 6 hydrogen atoms. You can replace any of the hydrogen atoms by the OH group, and what you get is something like this. Now, this molecule is called a phenol. Let's talk about the structure of phenol. Before we start the structure of phenol, let's remind ourselves the structure of benzene. We have studied the structure of benzene. It has a planar structure in which the carbon atoms are arranged in the form of a hexagon. The carbon atoms are arranged in the form of a hexagon. This is hexagonal shape that has 6 corners. Each corner is occupied by an atom of carbon. So there are 6 carbons. Now we can replace any of the hydrogen atom. Each carbon has got 1 hydrogen atom. So we can replace any of the hydrogen atoms with OH group, and we will get something like this. This is the structure of phenol. This bond angle is 109 degrees. It is almost the same as the tetrahedral angle. In phenol, the 6 carbon atoms are sp2 hybridized. Each of the carbon atom is sp2 hybridized. And these sp2 hybridized orbitals have arranged themselves at 120 degrees angle, just like this. This is 120 degrees angle. The oxygen atom has 2 unpaired electrons. If we look at the electronic configuration of oxygen, it is 1s2, 2s2, 2px, 2py, 2pz. It has got 2 orbitals, 2 unhybridized orbitals with 1 electron each. So one of these orbitals, one of these unhybridized orbitals will form a sigma bond with the sp2 hybridized orbital of carbon atom. For example, if this is the carbon atom, this carbon atom, I'm going to show this carbon atom here. So this carbon atom has got 3 sp2 hybridized orbitals, just like this. All these sp2 hybridized orbitals are arranged at an angle of 120 degrees. These are all sp2 hybridized. The two sp2 hybridized orbitals, these two orbitals, they will form a sigma bond with the neighboring carbon atom. For example, this and this. And there is an unhybridized orbital which lies perpendicular to the plane of the sp2 hybridized orbitals. This sp2 hybridized orbital will form a sigma bond with the unhybridized p orbital of oxygen. This is oxygen, and here it has another orbital which will form bond with hydrogen. So this angle is 109 degrees. It is almost the same as the tetrahedral angle. Okay? Acidity. In your previous classes, you have studied that an acid is a compound that can produce a hydrogen ion in water. For example, if this is an acid, Ha, if this is added in water, it will ionize, producing a hydrogen ion or a proton and a negative anion. Phenols show the same characteristic. They are acidic. They can ionize and produce a proton. For example, if you have got a phenol here, it will ionize as follows. O negative plus H plus. This ion is called the phenoxide ion. This is the reason that phenol is highly acidic.